All right, we want to look at the chi-square test for homogeneity, okay? Homogeneous means that there's like equal distribution throughout, okay? So like the gases in a room are homogeneous, that there's an equal proportion of nitrogen and oxygen and whatever other stuff is in the room, no matter what corner you look at in the room, right? Because that's because of diffusion and things like that. Homogeneity means that there are two populations, or three or four or five populations. We can check to see, do they have different distribution for the categorical variables? So if you think back to that mosaic plot where we had the types of cars that they have in the United States and in Europe and Asia, okay? Are those distributions the same or are they different, okay? This is the data from our last section where we looked at the different type of music that was playing and the different type of wine that people ordered, okay? And we talked about observed minus expected. So that 34.22 that we talked about, you get your observed minus your expected squared divided by your expected, and you would add up all of these and you get 18.28. Okay. The degrees of freedom is rows minus 1 times columns minus 1. So there were 3 rows, French, Italian, and no music. There were 3 columns, French, Italian, and other wines. So 3 minus 1 is 2. 3 minus 1 is 2. We get 4 degrees of freedom. Okay. And we can safely use the chi-square test as long as 20% of the expected value counts no more than 20% are less than 5, and all are 1 or greater. Okay. So if you have a 2 by 2 table, there's only 4 counts. So they all need to be greater than 5. But in our 3 by 3 table, we have 9 counts. So we have enough room that 1 could be less than 5. But if you look at our expecteds, 34, 30, 34, 10, 9, 10, 39, 35, 39, we're good. All of our expecteds are greater than 5. So we're all set. All right. So the chi-squared with 4 degrees of freedom, okay, 18.28. We see row minus 1, column minus 1 gets me 4 degrees of freedom. So I look at 4, 18.28. Where do I see 18.28? I see it way in between here and here. So any alpha less than or greater than 0.0025, this is where I am able to reject all of these alphas. So I could reject at the 0.05 level, reject at the 0.01 level, I could reject at the 0.0025 level, and this is the fail to reject alphas. Okay, so my p-value is somewhere between 0.0025, so it's smaller than 0.0025, but bigger than 0.001. Okay, now the cool thing is your calculator can do this, but there's some places on your calculator that we're going to have to go that you might not have been before. So if you hit matrix right here, second x inverse is this matrix button, okay? And you would want to edit your matrix. The first thing it asks when you go to edit is how big is your matrix? We have a 3 by 3 matrix, 3 by 3. And then as you enter in values, it just takes you right across each row, okay? And you just fill in the counts that we got. And the nice thing is you don't actually need the expected counts, because if you do a chi-square test, so I'm going to quit out of here and hit stat, tests, and down at the bottom, this is not a goodness of fit. This chi-square test is both for homogeneity and the upcoming independence, okay? The observed is in A, and I just say, I tell it where to calculate the expected because it has everything that it needs to know. I don't need to inform it of a model like I do with the goodness of fit test. It doesn't need to know the model. It just uses the table because it knows the totals to calculate the expected for me, okay? And so I can calculate this, and it says my chi-squared value is 18.27, 18.3, and my p-value is 0.00108, which is right in that range where I said it would be, okay? So we would reject the null that the choice of music is the same regardless, or choice of wine is the same regardless of what music's playing, and we would say there is some sort of relationship where playing a different type of music leads people to choose a different type of wine, okay? So good luck. and farewell.